We're changing the Earth. We can also change Mars, of course, over a period of many decades, but we can change Mars to become more Earth-like.
Today marks the end of an era and the beginning of a new one.
It would be so exciting to wake up in the morning and think that that's what's happening.
There is life on Mars.
In a groundbreaking discovery, astronomers have completely changed our view of Mars as an empty and lonely place, revealing its mysterious core. Contrary to what we expected, Mars once had warmth, liquid water, and the potential to support life. This incredible breakthrough was made possible by the diligent investigations carried out by the Insight Rover, which delved deep into the planet's interior, uncovering its seismic activity. After a challenging 5-year journey, Insight has provided scientists with a clear understanding of Mars' enigmatic core, fulfilling our long-held desire to explore it. With this newfound knowledge, our dream of eventually living on Mars is becoming closer to reality. So how does Mars' core differ from Earth's, and how did Insight uncover this core? And most importantly, what Michio Kaku has to say about this discovery. Let's find out. To truly appreciate the significance of Insight's achievements on Mars, it's important to understand how scientists unraveled the mystery of Earth's core over a century ago. The key to this understanding lies in the study of seismic waves, which are shock waves that travel through the depths of our planet. Seismic waves can originate from natural events like earthquakes or from controlled explosions created by humans. By analyzing how these waves behave as they pass through different materials, scientists can deduce the properties of those materials. Just as light waves interact with objects by being transmitted, reflected, absorbed, refracted, polarized, diffracted, or scattered, seismic waves also change their behavior when they encounter different substances. Seismic waves primarily come in two forms, P waves and S waves. P waves, also known as primary waves, are compressional waves that make rocks vibrate in the same direction as the wave's movement. They are the fastest seismic waves and arrive first from the earthquake's center. On the other hand, S waves, or secondary waves, are shear waves that cause rocks to vibrate perpendicular to the wave's movement. They travel at around 60% of the speed of P waves and typically arrive after the P waves have passed. In 1806, scientists made a significant discovery. Seismic waves traveled at slower speeds through Earth's core compared to other regions. They also observed a fascinating phenomenon. S waves couldn't pass through the core, while P waves could, but with a change in direction of the core's boundary. Based on these observations, scientists concluded that Earth's outer core is in a liquid state, surrounded by a solid mantle. Further investigations deepened our understanding of Earth's core. In 1936, researchers observed seismic waves bouncing off the inner core, indicating a transition from a liquid to a solid state. These groundbreaking discoveries, resulting from meticulous seismic studies, greatly contributed to our understanding of the complex layers that make up Earth's core. Now, let's fast forward nearly a century to explore Mars' interior, where scientists have used similar seismic techniques to uncover extraordinary findings. In 2018, the Mars rover Insight began a mission to analyze Mars' crust, mantle, and core comprehensively. A crucial part of this mission involved deploying a seismometer called the Seismic Experiment for Interior Structure on the Martian surface. This instrument was specifically designed to measure seismic activity and create precise 3D models of Mars' interior. During its 4-year active period, the Insight mission made a remarkable discovery on Mars. In 2021, 2 significant events occurred on the opposite side of the planet, capturing the attention of scientists. First, Insight recorded a massive Marsquake, surpassing any previously detected seismic activity. Second, a meteorite impact caused a seismic disturbance. These events happened far from Insight's location, providing a unique opportunity to analyze the seismic waves traveling around and through Mars, granting researchers an unprecedented look into the Martian core. Scientists compared the travel times of these seismic waves through the core with those confined within the Martian mantle, and by integrating this data with other seismic and geophysical measurements, they estimated the density and compressibility of the materials encountered by the waves. Surprisingly, the findings revealed that Mars' core is uniformly liquid, unlike Earth's core, which likely has a solid inner core surrounded by a liquid outer core. possibly with an even denser innermost core. Further investigations showed that Mars' core contains a significant amount of lighter elements dispersed within it. On average, these elements contribute nearly a fifth of the planet's weight, with sulfur being the most abundant, along with smaller amounts of oxygen, carbon, and hydrogen. This unexpected composition highlights the unique geological makeup of Mars. These discoveries indicate that Mars' core is less dense and more compressible compared to Earth's. On Earth, the activity within the core, known as the geodynamo, generates the magnetic field. In simpler terms, heat flows from the inner core to the outer core, creating currents in the conductive fluid within the mantle. As the planet rotates, these currents can twist, generating a magnetic field. This magnetic field then interacts with the fluid motion, resulting in a secondary magnetic field known as the dynamo effect. This mechanism forms the basis of Earth's self-sustaining magnetic field. Previous studies on Martian magnetism suggested that the presence of lighter elements in the core could have played a significant role in the loss of its dynamo and subsequent magnetic field. With a better understanding of Mars' core composition, scientists can now reconstruct the planet's history with greater accuracy. A planet's core characteristics provide valuable insights into its formation and evolutionary history. Earth's unique core composition allows it to generate a magnetic field that shields us from solar winds, preserving our planet's water and supporting the existence of life. In contrast, Mars' core lacks the ability to create this protective shield, making it inhospitable for known life forms. These investigations not only help in identifying potentially habitable exoplanets, but also enhance our understanding of the various ways planets can form, grow, and evolve over time, even when they originate from similar materials around the same star. The Insight mission, which ended in December 2022, has had a lasting impact on our understanding of how planets form and change. It collected high-quality data during its 4-year exploration of Mars, providing valuable insights into the planet. This mission shows the importance of scientific exploration and discovery. Recently, astronomers made an interesting discovery about Earth's magnetic field. They found that a weak spot in the magnetic field is getting worse, creating a crack in a specific location on our planet. If you missed the discussion about this discovery, it's recommended that you catch up on this exciting development. Besides revealing groundbreaking information about Mars' core, the Insight mission also uncovered other fascinating discoveries about the planet. It detected over 1,300 seismic events, with more than 50 of them showing clear signals that helped pinpoint their location. The region known as Cerberus Fossae, which has evidence of recent volcanic activity, had the highest number of high-quality seismic events. These findings suggest that Mars has had periods of geological activity in the last 2 million years. The most notable seismic events happened in mid-2021, with Insight detecting all 6 of the largest events since then. The most recent event in May 2022 had a magnitude of 5 and caused shaking throughout the planet for at least 6 hours, showing how dynamic Mars' interior is. Insight also provided information about the major layers of Mars, such as the crust, mantle, and core. Surprisingly, the crust beneath Insight was thinner than expected, measuring around 15 to 25 miles, 25 to 40 kilometers, thick and consisting of 3 layers. The top layer of the crust is about 6.2 miles, 10 kilometers, thick and less dense compared to the lower crust. Another surprising finding was that Mars' core is much larger than previously believed, with a radius of approximately 1,120 kilometers. The lower density of the core suggests the presence of lighter elements mixed with molten iron, explaining why the core remains molten despite cooling down over time. By studying seismic waves traveling from the upper mantle to the surface, the Insight mission has made remarkable discoveries about Mars. It revealed the presence of a strong and cold outer shell called the lithosphere, which is about 310 miles, 500 kilometers, thick. This lithosphere sets Mars apart from Earth because it sits above a relatively cooler mantle. Understanding the composition and structure of Mars's layers, as well as how heat escapes, has given us valuable insights into the planet's geological history and its potential for supporting life. Insight's findings have greatly improved our understanding of Mars's surface conditions and its evolution as a possibly habitable planet. In addition to exploring Mars' interior, the mission has collected important data about the atmosphere and weather. Using its weather sensors, Insight detected thousands of passing dust devils. Although the mission's cameras didn't capture direct images of these dust devils, Insight's pressure sensor recorded the changes in pressure caused by these whirlwinds. The seismometer also detected surface movements caused by the dust devils, similar to the effect of a huge vacuum cleaner pulling on the surface.
It will take centuries to terraform Mars. Mars is a gigantic planet, roughly on the order of half the size of the planet Earth.
Mars has been a source of fascination for astronomers and science fiction fans alike for decades.
So thanks for watching. If you enjoy watching this video, give it a thumbs up and subscribe for more.